here are the notes for lesson 3.6, sequences of transformations. So you will be able to identify a sequence of transformations that maps one figure to another inside and outside of the coordinate plane. So some of the questions you'll see will ask you to do this on the grid, and then some of the questions that you'll see will not have any grid lines. You'll just have to figure it out without the grid, okay? If you are given a grid, I'll explain to you the difference between when you're given a grid as opposed to when you're not given a grid, all right? So when more than one transformation is applied to an object, this is called a sequence of transformations. So a sequence of transformations is literally when you're doing more than one transformation in one question. For example, you may have to map a figure, by doing a translation and then a reflection or a rotation. So mapping just means moving something to a different location. And when we talk about mapping one point or one figure over another, it means that you're going to move it in such a way that they overlap. Okay? So when more than one transformation is applied to an object, that's called a sequence of transformations or a composition of transformations. And it's sometimes called composite transformations. Okay? If you transform A or point A, you label its image A prime. If you then go ahead and transform A prime, you label it A double prime. So you want the number of transformations you're doing to correspond with your prime notation, okay? Because if you were to go ahead and transform A double prime, then that image would be A triple prime, all right? So two figures, this didn't have an S before, I put one in, so do the same. Two figures are congruent if and only if one can be mapped to the other by one or a sequence of rigid motions. And if that's not the case, like in the case of a dilation, a pre-image and its image, once dilated, will never map to each other because one is going to be bigger than the other, so they're not going to overlap, okay? So with rigid motions, they should always be able to be mapped using one or a sequence of transformations. In this case, for example, if you look at what happened with triangle CDB, it was transformed, right? It was transformed by a translation over this vector. So a vector is when you go from, like in this case, B to B prime, all right? We didn't get to talk about vectors in detail. Hopefully we'll get a chance to do that soon. Because it was in, I believe, unit 3.2. It was in lesson 3.2 or 3.1, can't remember. All right, so the vector is basically the translation, the slide from one point to its image, okay? So clearly we translated from B to B prime, but we don't know what the exact translation rule was. So whenever you're dealing with figures that are not within the coordinate grid, you're not going to be able to give a specific translation rule because you don't know, right? You don't know what the coordinates of B are. You don't know what the coordinates of B prime are, so you can't really figure out what the rule was, all right? So in that case, you're just going to state it was a translation. Then, once we translated this figure, we also reflected it. So it's the translation, then a reflection in the y-axis, okay? Now, does order matter? So when you're doing a sequence of transformations, you need to figure out whether order matters or not. And as you can see here, so we have two of what looks like the same rules, right? But in this first question, the translation is first, and then the reflection. All right? So we did the translation, which was, the rule was to move it each point 3 times to the right, and down 5. So I did that. Please do this yourself as well. And then after that, the directions were to reflect it in the y-axis. And I did that as well. And so A double prime, B double prime, C double prime ended up here. All right? And then once I flipped that rule around, so it was in this order for the first sequence of transformations, and then switched the order in the second sequence. And as you can see, once I did the reflection in the y-axis and I translated it using the same rule, it ended up in a completely different place. Okay, so order definitely matters. Order definitely matters, okay? And we're going to get to that. We're going to get to some Regents questions where you're going to have to pay attention to order. And there's a specific way to read a sequence of transformations. And we'll talk about that tomorrow. So let's get to the guided problem set. I'm going to just discuss the first two with you, and then you're going to do the last one yourself. All right, so here it says determine a sequence of transformations that would map TUWV to T prime, W prime, V prime, U prime. I did this myself, and there's more than one answer to this question, so don't get stressed out about it if you did it a different way or if you want to do it a different way. I'm just going to show you the way that I did it in the interest of time and to kind of try to keep this video under 7 minutes, okay? So I looked at this and I was very clear that there was a reflection because it looks like this figure flipped, okay? So I did the reflection first. So, of course, these are the coordinates after the reflection, okay? But then I noticed that the image is over here. So in order for me to slide it so that W prime coincides with W double prime, should be, I noticed that I counted 1, 2, 3 to the right, down 1. Okay, so I concluded that the rule or a sequence of transformations that would map this onto that would be to reflect in the x-axis and then move each point 3 units to the right and 1 down. Okay, some people might have done it a different way. Like I said, more than one solution to this. Okay, now for the second one, notice we do not have a coordinate grid, and like I said, it's very hard to determine what is the reflection, or rather the translation rule, if there was a translation, without a grid. And in this case, there is, because what I would do here is I would translate through this vector right here. By vector, I mean the distance from B to B prime. Okay, so if I moved this down here, right, move that down and then I flip it, right? So if I moved that, which would be a translation slide, ooh, that is super sloppy, a translation, and then a reflection. So if I move that and then flipped it over, and the translation would be a translation and then a reflection over segment AB. Move that over and then flip this, right? Flip this side, flip it, and it should coincide or map or lay over each other. So reflection in segment AB, okay? Again, there's another way to do this. There's more than one correct answer, okay? So don't get bogged down by, oh my God. And, you know, this could also just be simply a reflection in the y equals x axis, okay? Because if you think about it, if I put a diagonal line through here, right, that's the y equals x axis, and then I flip it, that it's one, you can, a sequence of transformations is sometimes able to be done in just one transformation. But when they ask you what is a sequence, you do have to give an answer that includes more than one transformation. Okay, and again, we will go over this and I will clarify any misunderstandings you have. I want you to go ahead and try number 3. Oh man, I wasn't able to keep this under 7 minutes. Sorry about that. I want you to go ahead and try number 3, bring it in tomorrow, and I'll see you tomorrow and we'll talk more about this. Have a good evening. Bye.